I'm going to take the diesel paper that we're all familiar with because we've been using it for the reviews, and reminder that it's a study that was conducted to determine factors that affect the success of rehoming, so we don't have a single risk factor in this study. When you went through excuse me, the statistical methods would come up with something. You come and you will have seen this, and whether it made sense to you or not will depend on your other background. But it starts by saying we did descriptive and univariate analysis conducted using crosstabs, that x squared is a chi-squared, and we calculated odds ratios. So this is really a fancy way of saying, when we say univariable analyses, that we looked at the relationship between each variable on its own and the outcome. Now they've gone through, and all of that text there is explaining a whole lot of things they did about fitting a model. Really, all you need to take away from that is the fact that there was a multivariable model. Okay, they've used multivariable logistic regression, which I haven't highlighted, but it's in that text. You don't need to understand anything else. They also looked at a Cox regression model, which was a survival model. So really the key here is you're not looking to understand every single thing mentioned in the statistical methods, but it can be useful to scan it and see, okay, they did a multivariable model, which one did they use? And you're looking for logistic regression, linear reg, survival analysis, and Cox regression is a form of that if you want to. Otherwise, skim it, see it's a multivariable model, and move on. Okay, so let's have a look at the results. And what you see here is, univariable analysis. There were 93 variables that were included in the analysis and grouped as followed. Okay, and so what that's telling us, the authors looked to see if 93 variables were associated with the outcome. The paper didn't show us all the results as there were too many, but others will show you the results if there wasn't as many variables as that. They then looked at those variables that had some kind of relationship to the outcome, and they built a final model. They built a model through a process of model building. And the key thing is, if you want to know if something is a risk factor after accounting for confounders, then you need to go and look at a table that will say something like multivariable logistic regression results or adjusteds. They're the sort of words you're looking to. And in this paper there was such a table, and it was called the results of a multivariable logistic regression. And I'm going to interpret this for you with the size. So the size of the dog is associated with adoption success after for controlling for confounders when compared to small dogs. And the reason I know it's compared to small dogs is because the small dogs are the one. They're the comparison group. Okay, and the odds ratio is 1.8 for medium dogs. We know how to interpret that 1.8. We've done it before, but it's saying after controlling for confounders when compared to small dogs, medium-sized dogs were 1.4 times more likely and large dogs 2.4 times more likely to have an unsuccessful adoption. All right, and so the key in this statement is after controlling for confounders. And you might say, well, which confounders were those? If we look at that table, it was quite a long table because it was the whole model. One of the confounders was the center. Okay, and if we scroll down the table, you'll see there was a whole lot of other things that were included. So the behavior problem reported by the owner effort compared to expected, was the dog sick, so on and so forth. So what we're saying is that size, after we adjust for the center where you took the dog from, after we adjust for owner expectations, whether there were children, and everything else that was in that table, it was 1 point times more likely. Okay. All right, so let's have a look at this one. Just to reiterate, again, the referent is 1, and we can say after controlling for all other variables in the model, if the dog was sick soon after adoption, it was over 3 times more likely to have an unsuccessful adoption. Okay, All right, so if we now think about how do we actually put this into practice? Well, what I do in terms of identifying confounders, whether this be at the start when I'm designing a study or when I'm looking at what might be in a paper, is I need to firstly know, is there a particular outcome of interest? And there should normally be. Then I might have a couple of factors that I'm particularly interested in. Remember, a confounder doesn't exist unless it's in the context of a relationship. Okay. I list everything that I can think of that's associated with the outcome. Then I might think about everything that could be associated with the study factor. Now remember, it has to be a risk factor, but it also has to vary between the two groups. So it has to be on both lists in order for it to be a confounder. And only those variables that appear on both lists are potential confounders. And so if I'm doing this at the study design stage, well, that's my list of things that I have to collect data on. And this is why when we conduct epi studies, the surveys often have lots and lots of questions, because they're capturing the data about potential confounders so that we can run multivariable models. Now, the final thing I do is I kind of do a quick look and I think, are any of these potential confounders on the causal pathway between the relationships of interest? Often, though, that's actually practically very hard to be 100% sure of. So you'll often see quite convoluted arguments and debates between subject matter experts as to whether something is a confounder or whether it's an intervening variable. So unless it's really, really obvious, I wouldn't be eliminating anything at that stage. Okay, so just to reiterate, you list everything that's associated with the outcome. You list things that are likely to be associated with the study factor, and so therefore likely to vary between groups. If something appears on both lists, it's a potential confounder. You then want to check that it's not an intervening variable, so it's not on the causal pathway. And then that tells you, if it's at the study design stage, what variables you need to collect additional data on to allow you to control for it, or maybe you might control at the design stage. And if it's at the point of view of evaluating the literature, then I'm wanting to go through and make sure that, okay, have those things that I think are particularly important been controlled for. I look to see, are they in the models, was data collected, and so on. In truth, confounding will always be in the background in epidemiological studies, because you can only, with the exception of randomization, control for confounders you know. So if you don't know something's a confounder, then you won't collect data on it and you won't do anything about it at the design stage. So randomization is the only approach that, when done well, removes all confounding.